How can we solve this definite integral? You might try to set up a Riemann sum. Try to solve it as the limit as the number of rectangles goes to infinity of the width is 3 minus 3, so 6 divided by n, times the sum of plug into your function, your starting value of -3 plus I copies of your width, so 6 over n times I, where I goes from 1 to n, and you set up this Riemann sum. What is the function? This is the function, so this piece here just becomes the sum from I equals 1 to n of f is the square root of 9 minus x, this whole thing, -3 plus 6 over n times I squared. Okay, well, first of all, this is a mess, right? Like trying to solve this out, that's a mess. But second of all, it's not just messy, it's like, how would you do it? How do you find the sum of you expand this and get some I squares and some i's, and you would know summation formulas for those, except there's the square root symbol, and that square root messes it up. We don't have a formula for how to find the summation when there's a square root. This square root symbol here is messing everything up. It's messing everything up. So we can't find this. We can't solve this using a Riemann sum. We're going to need another approach to find this definite integral. And the approach we're going to use is we're going to think about geometrically. And so what I want to do is I want to sketch the graph of y equals the square root of 9 minus x squared. But it may not be immediately obvious to you what this graph looks like. Okay, maybe you have graphing technology, and so maybe what you can do is you can go ahead and type this into your calculator or whatever your favorite graphing app is, and you graph this out, and you see that when you graph this, you end up with something like this. And you're like, is it an upside down parabola? No, when we look closely, it actually looks like a semicircle. It's half of a circle from -3 to 3. It's a semicircle. Why is it a semicircle? How did we get a circle, half of a circle, from this? Well, I'll show you why. The reason this comes out to be a circle is because what we can do here is we can do a little bit of algebraic manipulation. I can square both sides. I get y squared is 9 minus x squared. Bringing the x squared over, x squared plus y squared is 9, but 9 is just 3 squared. And this is where you can think back and remember that this is the equation for a circle of radius 3. This is your circle of radius 3. Now, if that had been like a 25, a 5 squared, it would be radius 5. But here it's a circle of radius 3, which is why I get, well, this is only a semicircle. If I had graphed this instead, at some point in high school, you were given equations like this, and you were asked to graph them. And when you graph that, you would get an entire circle. It would be going not only up to +3, but also down to -3. So you would have an entire circle. So why is it that when I graph this guy, I only get the top half of the circle? The reason for that is because when I move from having y squared equals this to going up a step, I would actually have two solutions. One would be that y is the square root of 9 minus x, but the other possible solution is that y is the negative square root of 9 minus x squared. So both of these are solutions to y squared is 9 minus x squared. This is just like from the fact, like if you have something like, I don't know, I don't want to use the same letters, so let me make up a new letter. If you have something like a squared is equal to 4, you have two solutions. A is both plus or minus 2, right? Plus or minus 2, both squared to 4. So exactly in an analogous way, so let me erase that, but in exactly an analogous way, you have when y squared is this, y could be the positive or negative. The positive square root corresponds to this top half. It corresponds to this top half of the graph, whereas the negative square root corresponds to this bottom half of the circle. But here, since I was given the positive square root, I'm just being asked to solve what is this area. What is this area? And so you can say this area will just equal half the area of the circle, where it's a circle of radius 3, half the area of a circle. So it's just 1/2 pi times my radius, which is 3 squared, which is just 9/2 pi. 9/2 pi. What if I had instead been asked, well, what is the area from, say, 0 to 3 of 9 minus x squared dx? Well, now this would only be asking me from the area from 0, from x equals 0 to x equals 3. So this would just be asking me for this area from just 0 to 3. And so that would just be this 1/4, 1/4. This would be just 1/4 the area of the circle. And so that would end up being 1/4 of pi times radius squared, or 9/4 times pi, right? Okay, and finally, I could have been asked with the negative solution. So I could have had the problem being posed as what is the area from, say, I don't know, let's say -3 to 3 of the negative square root of 9 minus x squared. And now that's just asking me for what is the area of the bottom half. What is this area of the bottom half? Right? What is that area on the bottom? And it's the same as the area on the top. It's the exact same as the area of the top half, right? It's going to be the same. It's still going to be 9/2 pi, except since it's on the bottom half, it would be negative. Okay? So whenever you have a problem like this, with something of this form, it doesn't have to be 9. It could also be maybe 16 or 25. That's just changing the radius. But when you have a problem like this, just draw the picture of the corresponding circle, semicircle, a quarter of a circle, however much it is, and then figure out, okay, it's just half the area of the circle, or a quarter of the area of the circle, or the bottom half, so it's negative, right? And just use the geometry to answer the problem.